A uniform cylinder of radius r and mass m can rotate freely about a stationary horizontal axis O. A thin cord of length L and mass m is wound on the cylinder in a single layer. Find the angular acceleration of cylinder as a function of length x of the hanging part of the cord. The wound part of the cord is supposed to have its center of mass on the cylinder axis. So let us understand what the question is saying. That here we have a cylinder and there is a cord on the cylinder like this. I'm showing it with red color. Okay, this is the cord. And now what happens? This cord starts coming out. And say x length has come out. Some x length has come out. Then they are asking us to find alpha, that is angular acceleration of this cylinder when x length has come out of the cylinder. And in terms of length x. Now to do this a question, it's better to convert this question into a simple one, like considering that a mass is at the it's going down, having an equivalent mass equal to the length of the cord. Okay, so length of cord is given to us, length L is given to us, and mass of cord, mass is given to us as m. Okay, and the mass of the cylinder is given as capital M. So that we have to solve. So I am writing as mx. Now some length is already there on the still left on the cylinder, wrapped around the cylinder. That length is L minus x there. So corresponding mass would be m of L minus x. Or you can also say that the total mass was m minus mx which has come out. That we have to see. Now simply we will solve the question. Like first we'll draw a free body diagram. FBD for rope or cord, whatever you say, of length x. Now we're drawing the diagram of it. So this is the free body diagram of the block. Tension T. Here the string is I've converted to massless. Okay, I've converted string into a box. And box related question we already have done. You might have done. It's easy to solve considering a box. And this is coming down with an acceleration say a. So the equation we can write it because this is coming down. That means mxg has dominated over tension, and it's coming down mx a. This is the first equation. Now comes the equation for the cylinder. For cylinder we write this is the tension and this is the radius vector. Okay, so the r cross force gives me torque. So torque is like in this direction. Okay, anti-clockwise torque. It is rotating this tension is rotating the cylinder in anti-clockwise direction. So we can write for torque RT, you can directly let I torque is equals to I alpha, RT equals to I A by R. Remember this A is same as this A because this is tangential. This A, okay, tangential acceleration. And this is also linear acceleration which is tangential only. What I'm trying to say is this is coming down and this part is also coming down with same acceleration. Okay, this is coming down box and this part also coming down with same acceleration. They cannot have different acceleration, otherwise it will not move together. That's a basic common sense, you can remember this. So log is equals to I alpha. So we can write like this, RT is equals to I A by R. But remember that this I is a mix of the rope still wrapped around the cylinder and the cylinder itself. That means I of cylinder plus I of chord, which is still wrapped around. And they have said, consider that a chord, whatever chord is left, to be at its center, to have its center of mass at the center of the cylinder. That means what we can do, first we write simple cylinder mr square divide by 2, and then leave the chord for the next line. So high chord, how can we write? It is a ring, isn't it? This chord takes the shape of a ring only. And for ring, this type of, we use mass into radius square. Now what is the mass? Mass is total mass m minus which has come out, m minus mx into r square. So this I have to take as a total moment of inertia. So now I write total moment of inertia as I equals to mr square by 2 plus m minus, sorry, r square, m minus mx into r square. Now we can write sorry, now we can write torque is equals to I alpha, where we can write mr square by 2 plus m minus mx r square, and this is torque is r into t, okay, and alpha. So t we have got as m, r square we can take common, so m by 2 plus m minus mx, okay, into what is left, divide by r. Yeah, alpha I have not written, so we can write a by, I'm converting this into a by r, okay, alpha is a by r, and this r has also come to a by r square, okay. So this r square gets cancelled, and finally we get tension is equals to m by 2 plus m minus mx. This is the tension we have got. Now we have also got another equation, if you see, which is mxg minus t is equals to mxa. This was the first equation. So it was, this was second equation you can keep. So mxg minus t is equals to mxa. Okay, this is the first equation, and this was the first one. So if I add the two, t gets cancelled, isn't it? And we are left with mxg is equals to m by 2, sorry, this is multiplied by a. So a also you can take common. So we have m by 2 plus m minus mx plus mx, and overall I'm taking a as common, isn't it? Right hand side only has one term, I have written that, and left hand side has 1 2 3 terms, 1 2 3 written that. So now we have mxg divided by, this can be cancelled, m by 2 plus m is equals to a, that is the linear acceleration. And since they are asking us angular acceleration, we'll find it. But first let me tell you what is mx. So you can use a unitary method, and the question is given uniform chord. So we can write like this: for L length, the mass of chord is m, which is given to us. Therefore for x length, the mass will be m by L into x. Only when chord is uniform you can do this. If it's non-uniform, then relation would be given how mass and length are related, and then you can do an integration to find for the mass for the x length. This has to be replaced, so we write acceleration is equals to mxg divided by, then L you have, take the LCM also, m plus 2m, then send the 2 at the top. The final acceleration we have got. Now alpha is equals to a by r, so we also put r in the denominator upon lr m plus 2m, and that's the answer to the question.